I'm with the Econ Tutoring Center, and today we're going to be looking at combinations versus permutations. So I have already written out the equation for combination and the equation for permutations, but everyone wonders what's the difference. So a combination is something where the order does not matter, which would be like, imagine if you were making a salad. You put all the things together and you mix it up and the order doesn't matter of like how you put things in or what happens in the end. But a permutation, order does matter. So in that case, it could be something like the combination, like your lock on your phone. The order of the numbers you put in matters. Or places in a competition, like first place, second place, third place. Like in that case, order does matter. So now we're going to look at two examples of how to apply these equations in two situations. So let's work with combination first. So a good example, well, let's say you have a group project in your class, right? And let's say you can choose from 8 people. So the total people in your class, there's 8 people, but you need to come up with a group of 5 people, right? So let's see, how would we apply this equation? So in this case, in both of these equations, n equals to the total number of whatever observations, people, just the total number of like what you're looking at. And then R would be how many you choose. So in this case, R would be your group because you choose 5 people out of the 8. So, or number you choose. So now let's look at this. So if the total 8 is n and 5 is r, then we just plug those in. So if you've never seen a factorial notation before, in this case it means you would take the number 8 and multiply it by every number until you get to 1. So in this case it'd be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And that's what that notation means, is you're multiplying it by every number. So now we can do this for both parts of this equation. So you do 5 times 4 times 3 times 2 times 1. You don't have to do this, but it's good to write it all out when you're first learning how to do this, so then you can see which numbers cancel and which ones don't. So in this case, 8 minus 5 would give us 3 factorial, so that'd be 3 times 2 times 1. So you'd be multiplying all these by this. So now, to make this simpler, if you notice, you can cancel out some of these numbers because you're just multiplying all of them. So the 5s cancel the 4, 3, 2, 1, just like this. So all you're left with is 8 times 7 times 6 divided by 3 times 2 times 1. So if we simplify that, 336, and that's what you get by multiplying 8 times 7 times 6, divided by 6, which is what you get if you multiply 3 times 2 times 1. Which in this case would give us 56. And this number means that out of all the 8 students in the class, you can have 56 different combinations or different groups, including 5 people, if order doesn't matter. And that's what a combination is. Now let's take a look at permutation, which is a little different, as you can see in the formula. And in this case, order does matter. Okay, so now we're going to look at permutations. And so let's say we'll have an example of there's 6 people in a pie eating contest, right? So your total number of people would be 6. And then now, since it's a contest, order does matter. So we want to know who could get first place, second place, and third place out of all 6 of them. So R, in this case, would be the number we're choosing. We're choosing to determine how many different options or possibilities there could be out of this 6 to win first, second, or third. So in this case, R is equal to 3 because there's first, second, and third place. So now we just plug those into this equation, just like the other one, right? So we get 6 factorial divided by n, which is 6, minus 3 factorial. And since this is outside the parentheses, you can do the subtraction first in case you didn't catch that. So let's draw it out like we did in the other one. So in this case, it would be equal to 6 times 5 times 4 times 3 times 2 times 1, just like the other problem. And then in this case, 6 minus 3 equals 3. So now 3 factorial would be 3 times 2 times 1. And again, we see here that certain numbers can cancel out. So we cancel those out since it's division. And then you're left with 6 times 5 times 4. So that equals 120. So out of all 6 participants in the pie eating contest, there's 120 different permutations possible. So different orders that someone could win first, second, and third possible. Thanks for watching our video. I hope this helped. And if you have any questions, leave a comment below or visit us in the tutoring center.